Alright, let's talk about finding the surface area of three-dimensional figures. So we know that height is very important when we're finding the area of a shape like a parallelogram or a triangle. Also important when we're finding the area of a 3D figure. So in a prism and cylinder, the perpendicular distance between the bases is defined as the height. So whether on the left you have what's called a right square prism or a cube, that's on the left. On the right, we have what's called like an oblique prism. So that's when the bases aren't directly on top of each other, but you would still refer to the height as the perpendicular distance between them. Okay, the actual side length that's going diagonally, we're going to talk about later, that's called the slant height. But a height is always, for a prism, the perpendicular distance between the bases. For a pyramid, it's the top straight down perpendicular to the other base. Alright, so like I just mentioned, a pyramid and a cone, the perpendicular distance from the base to the vertex is the height. So sort of like if you look on the right, that oblique pyramid, it kind of reminds me of like an obtuse triangle where you have to draw the height outside of the triangle to find the height. In this oblique pyramid, same idea. So it's the very top point where all the faces meet, perpendicular down to the base or a plane containing the base. Alright, so on the left, the right pyramid, the right pyramid on the left, it's straight down in the middle of the pyramid. That's the height. Okay, now pyramids and cones have a different type of height. So the slant height is the perpendicular distance between the vertex and the edge of the base. So you can see in that picture there, if you were to draw the net of that pyramid, the four triangles going around the sides of the pyramid, the height of those triangles is the slant height. Right, so slant height is kind of like what it sounds like. It's the height on a slant, or like a diagonal. So you go from the vertex straight down to the edge of the base. Alright, and the same idea in a cone. The slant height is that diagonal height. Whoops, I got a little update on my phone. I should probably mute that. Alright, slant height. And we use L to represent slant height, I guess because it's the second letter in the word slant. S, you refer to like side lengths, or sometimes looks like an 8. Okay, so surface area, you're going to be asked to find the lateral area sometimes find the total surface area. The lateral area is the sum of all the lateral faces. Alright, what are those? Those are all the faces of the solid except the bases. So in that picture on the right, the orange would represent the lateral area, and the blue is the base. So the surface area is when you find the lateral area and then add the two bases. To find the total surface area of a prism, find the area of all the faces, including the bases, and then add them up. For a pyramid, you have to find the area of all the faces and then the one base and add all them up. So total surface area is just you're drawing the net and you're finding the area of all the polygons. So let's try a couple. Alright, and it helps to draw a net here. So this right triangular prism has two triangles that have a height and base of 3 and 4. So if we do base times height divided by 2, we get that each triangle, each base, has an area of 6 square inches. And there's 2 of them, so just the bases is going to have a total surface area of 12 square inches. Then we have the lateral area, which is everything but the bases. And in the lateral area, we have that big rectangle that's 8 by 5. Alright, so that's going to have an area of 40 square inches. Alright, so that's like this top part right up here. Okay, then you have this bottom rectangle, which is 4 by 8. So 4 by 8, 4 times 8 would give us 32 square inches. And then you have this side over here, which is 3 by 8. So 3 by 8 would be 24 square inches. So if I was just looking for the lateral area, I would add up these three numbers here. So the lateral area comes out to be 96 square inches. Okay, so for the total surface area, we're going to add the area of the two bases plus the lateral area, and we get that the total surface area is going to come out to 108 square inches. Okay, so surface area is just like area, but of a lot of shapes, and you add them all up. So think of it as like the total amount of wrapping paper you would need to cover that right triangular prism.